Hi, welcome to iMotions webinar with Clarins. A warm welcome to you for joining us today on discussing how to use biosensors in fragrance and cosmetic research. During the webinar, feel free to drop your questions in the question box above, and we will answer them through the course of the hour. Please note that this is not a common chat, so your questions will only be visible to us. Some of the questions will be discussed live with us at the end of the webinar. The recording of the webinar will be available and sent to you later through your sign-up emails. Change the slide, please. Thank you. Today, we are very honored to have Laura Gilbert, Ph.D., one of our clients, joining us this webinar today. She is a project manager at Sensory Innovation Laboratories Clarins. She holds a Ph.D. in polymer physicochemistry and sensory analysis. During her 6 years at Clarins, she set up research projects to better understand consumers' perceptions and feelings in order to bring to market the most sensorial and emotional cosmetic formulas that bring well-being to consumers. From iMotions side, we have Samir, who is the Director in Corporate Solutions at iMotions. He holds a master's degree of Business and Economics. During his 8 years at iMotions, he accumulated extensive research experiences in fragrance and cosmetic research. We have Gandhi, myself, who is a Senior Product Specialist at iMotions. I hold a master's degree of Neurophysiology and Biometrics. I have been working with iMotions for 4.5 years, during which I have had opportunities of consulting biometric research in sensory testing and other domains. Thank you.
Thank you.
So, agenda overview for today, very fast before I hand over to Samir. You will first hear from Samir a brief introduction of iMotions and fundamental theories of how to use different biosensors for fragrance and cosmetic testing. Then Laura will introduce to you how she used iMotions and biosensors for fragrance testing study she has done with some very interesting results. Then myself will give you a live demo of iMotions platform where you will see how exactly a fragrance and a cosmetic study can be implemented in iMotions. Last but not least, some of the questions you have asked during the webinar will be discussed live by 3 of us. So feel free to drop anything you have in mind in the question box above. Cool, then let's get started. Samir, the floor is yours.
Thank you, Randy, for the introduction, and thank you everyone for joining this webinar. I'm just going to give you a short introduction into our company and our product, and then I'm going to walk through the different biosensors that we support. So iMotion was founded back in 2005 in Copenhagen, Denmark, where I'm sitting today. But today we have offices in a variety of different countries around the world, and we have more than 1,500 active clients across different industries. On the academic side, we are working with some of the best universities around the globe, like Oxford, Stanford, Harvard, MIT, etc. And on the commercial side, we are working with a lot of different types of commercial clients, all the way from market research agency, the automotive agency, manufacturing, FMCG, and all types of different brands. We have more than 10 global cosmetic brands, and we are working with more than 5 global cosmetic fragrance houses on both fragrance, aroma, and cosmetic testing. The reason that iMotion exists today is back in time, if you wanted to conduct a multimodal research design combining a variety of different sensors, you would need one system for galvanic skin response with its own computer and its own software, another one for eye tracking, a third one for facial expressions, etc. You needed to find a way to synchronize all these different sensors. You needed a tool for stimulus presentation, other tools for data analysis, etc. So it became like a huge setup with a lot of different softwares that had to talk together, and it would take a very long time to run a simple study. So what iMotion is, it's basically one platform that you install on one machine, either desktop or a laptop. And it not only takes care of the synchronization of all the different sensors, but it basically helps throughout the entire process of the study, all the way from designing the study, creating your stimuli, uploading your stimuli to iMotions, creating your study design, to connecting all these different sensors, and to collecting the data from the respondent. And then we have a variety of data processing and visualization tools in iMotions you can use to analyze the data. So just to walk through some of the sensors that we support, the first one is eye tracking. Most of you know what eye tracking is, but it's basically a sensor that is measuring the visual attention of a person. There are two main types of eye tracker. There are the screen-based eye trackers, which are used to measure the visual attention of screen-based stimuli. So these are just a small bar that you would attach under the screen, and then you can present anything on the screen to the respondent. And then for a more ambulatory or real-world setup, we also support eye tracking glasses. So these are a pair of glasses that you put on the respondent, and then you can basically run a study in like an ambulatory setup, for example, inside of a store, or like a pack design study or anything like that. There are three main types of analysis you can do in iMotions, which are all supported in iMotions. The first one is gaze replays, where you can basically select a respondent and see how they look through a stimulus. So where did they look first, second, third, etc. Another one is heat maps, where you can select a group of respondents, and then iMotions will automatically generate a heat map for you, telling you where the visual attention is most and least on any given stimulus. And the third one is probably the most interesting one. These are the areas of interest, where you can highlight specific elements of a stimulus, and then iMotions will automatically give you all the eye tracking statistics of all these different elements. So which elements did people look at first, second, third, in which order, how much time did they spend on these elements, the amount of fixations, how many respondents looked there, how many respondents missed that, etc. So that leads me to the next sensor, which is a facial expressions analysis. The advantage here is that you don't need any additional hardware. You can just use any webcam. A built-in camera of a laptop would work just fine. For the facial expressions, we use the Affectiva facial expressions technology. And it's basically a technology that is recording the face of a respondent through a web camera. And then through some advanced processing, it's calculating it's monitoring the muscle movements and calculating a variety of different emotions and behavioral matrix. So you will get all the individual muscle movements, such as brow furrow, smile, cheek raise, etc. And then you can also work with all the different emotions: joy, fear, contempt, surprise, anger, disgust, sadness, confusion, and sentimentality. And then you also have a variety of different behavioral matrix you can use to see how people are behaving to different, how they are reacting to different stimuli, such as engagement, which will tell you how much they are moving their face muscles. Blink rate is a great indication of cognitive load. You have the emotional valence, which will tell you whether they are responding positively or negatively, etc. So by just a web camera and the algorithm, you can get a lot of different signals that you can basically work with within any given type of research, especially within fragrance and cosmetics. And then you have a galvanic skin response, or EDA, electrodermal activity, which is a device where you put two electrodes on the finger, and it's basically measuring the sweat gland activity. In other words, it's monitoring how strong the emotional arousal is of any given respondent or emotional activity. So if you combine this with, for example, facial expressions will tell you which specific emotions the respondent is expressing to these stimuli or fragrances or aromas, and whether it's positive or negative. And galvanic skin response will tell you how strong these emotions are. So these two technologies supplement each other very well. The third one, or fourth one, is EEG. This is a device where you put electrode across the scalp in the area of the brain that you would like to measure, of course. And these electrodes are measuring the electrical activity on the scalp of the brain, of the scalp of the head. And in other words, it's measuring the brain activity on the surface of the brain. You can do a lot of different types of analysis with EEG. The two most important ones within fragrance and cosmetic research are probably approach avoidance behavior, which is measured by the frontal asymmetry. So the asymmetry between the left and right frontal part of the brain. This is a great measure for liking or neurophysiological valence, whether respondents are more likely to approach or avoid something, or showing more signs of positive or negative response to any given stimulus. The second one is workload. Is also a great measure of how much the brain is. It's a measure of how much the brain is processing. So it could be a measure of how complex the stimulus is or how difficult the task is to complete. These two, approach avoidance behavior and workload, can be calculated automatically in iMotions without exporting the data and working with it outside of iMotions. Then there is the ECG, or electrocardiogram, which most of you know from the hospital. It's basically you put electrodes across the chest or on the arms and on the legs, and it's basically measuring the heart activity. So in other words, it's giving us indication of heart rate, which is also a great measure of emotional arousal or emotional activity. But it's also giving us a heart rate variability, which is a great measure for alertness or long-term stress levels. So this is also a great device to use to understand how people respond to different type of products. Then you have EMG, electromyogram, which is a device that is measuring the muscle movements. So you can basically put it on any muscle across the body and measure the activity of the muscle. One great application here is to put it on the face and measure the facial expressions through facial EMG. So you would put 2 electrodes around the brow area of a respondent, and you would put 2 electrodes around the chin area of a respondent, and then that will give you the basically whether the respondent is showing signs of positive or negative emotional responses towards something. This is a great device to use in the application areas where it's not possible to use webcam-based facial expressions. For example, if someone is walking around in a store, or I had another project a couple of years ago where they wanted to measure people putting shampoo inside of a shower, where it's not possible to use webcam-based eye tracking because people are obstructing the face, etc. Then you can use facial EMG. These was the most important sensors that I wanted to just talk about today for these application areas. Now I'm just gonna quickly talk about a few best practices that we have experienced for the last couple of studies we have done with iMotions. So generally, when we do fragrance studies, and this is specifically to fragrance or aroma testing. So in fragrance and aroma studies, we generally always recommend using the combination of sensors that can measure arousal and valence. So galvanic skin response and galvanic skin response for arousal, and facial expressions analysis and EEG for valence, for example. We found that about 60 respondents is a good starting point for a cell. Then you can start looking into statistical significance, etc. And we have also found that it's not a good idea to present more than 10 samples or 10 fragrance aroma products to a respondent before you start introducing olfactive fatigue, which means that the respondent's ability to smell fragrances will actually decrease after 10 to 12 fragrances. So if you have more than 10 fragrances, let's say you have 20, we recommend then having 2 cells. So either 2 polls of respondents or the respondents coming back in 2 different days. The way we generally recommend setting up a study is everything will be set up, setting everything up in iMotions. All the instructions will be in iMotions. So in other words, the researcher will put the equipment on the respondent, leave the room, and only come back after the respondent has finished. That way we eliminate or at least minimize researcher bias. So the first instruction would be to take the fragrance, open the lid, or however we are exposing the fragrance, smell it, put it back, and then the respondent would click, and then we ask the respondent to sit back and relax for 30 seconds. And this is where we are recording all these different, the measures from all these different devices. The reason that we are doing it in the 30-second reflection period and not in the exposure period is that there are a lot of artifacts that has to be cleaned up if we do it in the exposure period. A, due to muscle movements. Two, due to a lot of responses are coming in that we see are due to the fact that the respondent are initiating a task rather than the actually underlying fragrance. So we have found good results doing it that way. And then after that, we always recommend presenting a survey with likability, purchase intent, associations, or whatever you would like to ask the respondent. The way we analyze the data in this study and in many other studies we have conducted is with the affective circumflex. It's widely used within psychology, very popular, and it's a two-dimensional way of categorizing emotions. So on the x-axis, you have pleasant and unpleasant, or positive, negative. So basically the valence, whether a response to a certain fragrance or aroma or anything is positive or negative. And then on the y-axis, you have the emotional arousal or the emotional activity, which is telling us how strong that response is. So in other words, when we use a combination of galvanic skin response or heart rate for arousal and facial expressions, NEEG for valence, for example, then we can start categorizing all these different products that we are testing. So if a product receives a positive valence with a high arousal, it's probably an activating or exciting product. If it has a positive valence with a low arousal, it's probably a relaxing or calming product. If it has a negative valence with a low arousal, it's probably a boring or ignored product. If it's a negative valence with a high arousal, it's probably an agitated, aversive, or stressful product. So that was all from me. So now I will hand it over to our client from Clarins, Laura Gilbert, who will talk about a little bit about how they use iMotions for aroma and fragrance testing.
Yeah.
Thank you.
Do you hear me? Yeah. It's okay?
Yes.
Yes. So thanks again, Samir, for the invitation. I'm very happy to be able to share my experience on a team that is very important to us at Clarins, the evaluation of the pleasure, sensoriality, emotions, and well-being provided by our product. So quickly to introduce Clarins, please, Samir, moves on to the next slide, please. Yes, thanks. We are a family-owned French company founded in 1954 by Jacques Courtin, and our headquarters are in Paris, and our projects are developed and manufactured at our French laboratories at Pontoise. And we have two brands, Clarins and My Blend, and 68 years of expertise in skincare, makeup, and spa. So in the next slide, you will see our iconic products with various sensory textures, oils, creams, serum, product for the face, for the body, for skincare and makeup, for all ages, all skin types, and all beauty concerns. And Clarins' success is based on our respect for women and the special attention we pay each customer. So attentive listening and ongoing dialogue are part of Clarins' DNA, and for a good reason, to help us meet our customers' beauty needs and aspirations. Thus, beyond the effectiveness of our products, we wish to offer our customers a real experience of well-being for each product. That is why the evaluation of emotion is a big topic of interest for us. So what is the definition of emotion? If you move, yes, thank you. As you know, the definition shared by most authors includes three components: a subjective or cognitive component, which means the assessment that the subject makes of its own emotional state, thanks to psychometric and cognitive methods. But one disadvantage is that people don't always tell the truth. They don't always know how they feel, and sometimes they don't always do what they say. So the second component is the visceral or physiological component, and as you have seen with Sami, we can notably measure the electrodermal activity, the cardiac respiratory activity, the cutaneous temperature, and the cerebral activity thanks to EEG or functional magnetic resonance imaging. And the third component is the expressive or behavioral component, because facial, vocal, and body expressions are also very good indicators of our emissions. So I think it's very interesting to have a multimodal approach to evaluate emotion and well-being. And now the study I'm going to share with you, if you can go to the next slide. Yes. Yeah. Yeah. So no, just before, yeah. Yeah. Nowadays, consumers are looking for cosmetics that bring them emotional benefits thanks to synergies of plants, odors, texture, and will improve their well-being and so there's beauty. So the objective of the study I'm going to share with you was to develop a multi-parametric method to evaluate the overall emotional experience provided by the scent of essential oils, which were incorporated in cosmetic body oils. And the aim was to objectify the relaxing or energizing effect of these essential oils. And the study was designed with the support of iMotions and the use of their platform. So, the product of our study were 6 body oils. You can go to the next slide. Yes. The product was where body oils consisted of mixture of pure essential oils, each diluted in a vegetable oil, and the products were divided into 2 categories: those that claimed toning, energizing effect, coded A, B, C, and they contain rosemary or sea buckthorn seed oil, or a mixture of essential oils, and those claiming a relaxing claim, coded for the study D, E, and F, and which were chamomile, lavender, or a mixture of essential oils. And 5 different methods were implemented. Yes, electroencephalography, which is the measure of the electrical activity of the brain. In particular, we have extracted the frontal alpha symmetry as a physiological valence indicator. We also use electrodiagonal activity, and we extracted the 3 indicators of the physiological arousal. We also set up an emotional questionnaire, which is derived from a published universal emotion and odor scale, which is about 9 emotional dimensions, which were scored in a 9 points intensity scale. Next method was an image evocating task, which is an indirect evaluation, 20 duos of images with a positive valence and a high or low level of arousal, issued from validated database, were successively presented to the volunteers, and they have to choose the image which best represents their feeling. And we calculated a dynamism score for each sense. And the last method was a hedonic questionnaire with 6 items, which were scored in a 5-point agreement scale. Yes, so 59 women aged from 29 to 65 years old participated to the study. They evaluated the 6 scents, which were randomly presented, and the whole protocol lasted 1 hour 30 per volunteer. And the first step was to record a baseline, followed by the phases of smelling odor during 30 seconds. Next step was a period of reflection in order to sync to the odor during 1 minute. And physiological signals were recorded during these 3 steps. And then volunteers answered to the different questionnaire, and the same process was repeated for each odor. So in the next slide, we'll see some of our results. Yeah. Yeah. So for EEG, you can see on the graph on the left, we know that the higher the frontal alpha symmetry is, the more positive the emissions are. No significant difference were found between the sense, but all other seems to induce more positive emotion compared to the baseline, as they result in a higher frontal alpha symmetry. And for the electrodermal activity on the right, the higher the non-specific skin conductors response amplitude is, the higher the emotional arousal is. No significant difference between were found between smells, but you can see that the A, which is rosemary, obtains the highest value, whereas the E, lavender, obtains the lowest one. And for the emotional profile, which was obtained thanks self-report, ABC significantly provide more energy than D, which is chamomile, and E, lavender, brings the most calmness and relaxation. And also we can see that rosemary was perceived as the most dynamizing, and lavender the most relaxing, which are in accordance with the literature. And lastly, for the indirect evaluation, the image evocating task, rosemary oil obtains the highest dynamism score, significantly higher than the lavender oil, which obtains the lowest, which is in accordance with the physiological parameters. And in the next slide, you will see the results of a principal component analysis. We performed a PCA to project our data on a two-dimensional plane in order to analyze the similarities and differences between our 6 male and from groups. And you can see that the horizontal axis can be assimilated to a valence axis, while the vertical one is assimilated to an arousal axis. And thus, by coupling all our techniques, physiological and questionnaires and image projection, we have highlighted 3 groups of smell, A and B, which were characterized by a positive valence and their toning and energizing effects, C, E, and F, which were characterized by a positive valence and a low emotional arousal, and D, which is chamomile, which was characterized by a more neutral arousal and more negative valence. So finally, we have succeeded in highlighting the toning or relaxing effect of our essential oils using multimodal methods, and we were thus able to show that our essential oils can stimulate both the body and the mind. Last but not least, I think what is important in the evaluation of the emotion is to use a multimodal approach when it's possible, because each method has its advantages and its disadvantages. So please, Sami, move on to the next slide. Conscious methods like questionnaire are simple to implement. Their assessment is fast and they are not so expensive, but they can have a social desirability bias because, as I said, people don't always know how they feel and they don't always feel what they say. For indirect methods like image evocating task, it is easy to implement, but it is really important to make an emotional normalization of the images beforehand. And lastly, for physiological methods, they give an objective evaluation of mind and body feeling, but yeah, it can be costly and really time consuming and also difficult to interpret. And physiological parameters are not directly related to an emotion in particular. So it is very important to combine with questionnaires. Yeah, so I thank you for your attention. And I also would like to thank iMotion for the support for the design of our studies, the data collection, and also the support for the interpretation. Thank you.
Thank you, Laura, for your sharing. We definitely learned a lot. Can you see my screen? Just get a confirmation.
Yeah.
Cool. Yeah. So now I'm going to just show you live in iMotions platform how to implement a fragments or a cosmetic research study in iMotions. Yeah. So as you see, this is iMotions platform. You can actually create a study, connect the sensors, collect the data, analyze, review the data, and last but not least, export all the data from iMotions platform. So everything in one platform. In order to create a fragments testing study, you first click the button here, Add New Study, and you give your study a name. Here you can tell iMotions what biosensors you choose for your fragrance testing, for example. And each of the options here is corresponding to a type or a name of the biosensors that can be used to collect a specific type of biosignals correspondingly. For example, from Laura's study, she used the EDA or GSR and EEG. Shimmer is the type of is the name of device that can be used to collect the GSR data. And through lab streaming layer, you can also connect the EEG headset with iMotions, therefore collecting EEG data. And we are not limited to only those two options. As you see here, we have more options here. And therefore, it means that we can also collect eye tracking, facial expression, the respiration or ECG data simultaneously with these two signals. And by clicking Add, you established a study you just created on the iMotions library. Laura, can I please kindly ask you to mute yourself? That we have some noise here. I don't know if it's from me or it's from her side. Thank you very much. After creating the study, you just add the respondents you would like to test on. For example, here I just give it a name, and by labeling the gender, age, and group, you can use them to differentiate the property of the respondents later. And then that will allow you to do the different group analysis based on those labels you give here. And of course, you can add more than one respondents. And next step is to implement the stimulus, as you see here on the top of the platform. It's a stimulus bar. And the stimulus is actually a terminology in iMotions we use to refer to the certain type of content that a experimenter wants to expose to their respondents during the data collection. In iMotions, we offer a wide variety of types of stimulus, and most seen ones are image and also survey slides for fragrance and sensory testing. So for images, you can use it as instructions to guide your respondents through the whole experiment process. And even for designing an image association testing to a certain type of product you're testing. And for survey slides, you can launch it right after the product testing, fragrance testing, and then put in the questions you want to ask your respondents right after they smell a fragrance, for example, like how likely you want to buy it in a shop or to what extent you like it. So those are the stimulus types you can add to the iMotions. And now I'm just going to jump into a study that I have implemented and conducted. It's actually been implemented before in iMotions. And then as you see, just to show you this whole stimulus design workflow. So in this study, in the middle of the screen, you can see a clear view of the stimulus we put in front of respondents during the data collection. So you can see the instruction of the study. In this study, we want to test 4 types of fragrance smells, and then to see that which one is reducing stress level more significantly than others, measured by biosignals. And as you see that we use the different biosignals here, for example, EEG, eye tracking, facial expression, and even more GSR, respiration, and ECG data. So you can see that all those data can be combined and simultaneously collected in one fragrance testing study. And then we guide this respondent through different steps like fragrance presentation, so smelling the fragrance, and then reflecting on it. So please reflect what you just smelled, and of course followed by survey slides to ask them how likely you want to buy, for example. And then ended up by a image association testing to see what feeling is evoked in this respondent by smelling that certain type of fragrance. And of course, the end of this product one. So in this study, you just repeat this procedure for 4 times because you have 4 types of fragrance to test. And in iMotions, it's also possible to flexibly design those order of those stimulus. So as you see here, that we designed the group of stimulus for 4 fragrances. So what I just described, we put that into one block, and then you can choose to randomly or fixed order present each of the fragrance to your respondent for data collection. So those are flexible and possible in iMotions. Yeah, and then after the study design, you connect the sensor with iMotions, you're ready to go for your data collection. So I'm very curious here about one question, Laura, because we see that you have implemented a very similar workflow for your fragrance testing iMotions. So can you share with us what you find that is the most helpful for you during your implementation of the study in iMotions platform?
Yeah, I think what I find really powerful about using iMotion is the ease of use of the platform, and also the flexibility in the presentation of stimuli instruction, as one can create presentation blocks for some stimuli and not others. There is a random order of presentation with these blocks, and all measurement methods, instruction, and questionnaire are managed in one place. So it was really, yeah, really easy to use.
That's very good to hear, and thank you for sharing. Yeah, the ease of useness is always what we're improving on, and then we'll still keep working on that. So thanks for sharing of that. Yeah, so continue with the after the data collection. So what you can see after it. Let's just go back to one of the stimulus we just added to the study. So after you finish the data collection, this is the replay window you can see and launch in iMotions platform. Here you will be able to see the image or the stimulus that you expose to respondents, so what they are watching, and overlaid by these orange circles. Those are gazes detected by eye trackers, telling you where people are looking at during this whole stimulus presentation. And on the right side, that's very interesting and also important for our fragrance or cosmetic research clients, is that we can record the face or the body behaviors during the data collection, and you can better observe their behaviors when they're smelling or applying the product. And below those camera recordings, you will see multiple streams of biosensors data. For example, you can see from the facial expression what they expressed on their face during the testing, and what is the GSR, so it's indicating the arousal level of their emotional intensity. And then you can see how fast his heart is beating, and you can see how fast he's breathing during this whole testing phase. And not only the raw data from biosensors, you can also get the analyzed data in iMotions and be presented together with the sensors, the raw signals. So as you can see, use frontal alpha symmetry as example. Samia introduced you that the frontal alpha symmetry is indicator of motivation, so approaching avoidance towards a certain type of stimulus. So here you can see that by adding this analysis tool in iMotions, we can compute this for you and visualize this for you. So this analysis tool is actually developed by iMotions, and you can add that directly in iMotions during your analysis phase. And not only this analysis tool, what I showed you, but also some more. So for example, using eye tracking heat map as an example. So heat map is telling you the visual attention of the whole analysis group. So where people are looking at most or where people are getting ignored. So you can see that in this image that people are associating their visual attention more to the stress element, for example, compared to other elements of the image after smelling or testing that certain product. And if you finished all the analysis in iMotions, you can just click the export button, and almost all the data you collected and analyzed in iMotions, including the camera recording, including the biosignals, and also the survey results, you can export all of them from iMotions, and there you will have exported file, and you get all the materials you need to proceed your further analysis, like what Laura did, or just to generate some beautiful visualizations for your presentation. So yeah, so this is the analysis flow. And because Laura, I see that you actually come up with some really interesting results from your study. So can you name 1 or 2 points that you find that iMotions tool can help you with your data analysis and interpretation?
Yeah. The support of iMotion was important on the biosensor part to properly analyze and interpret our physiological data, and we use also some of your algorithm to extract some physiological parameters. So it was really helpful for that. Yeah.
Yeah, those just for everybody's information, this analysis algorithm that Laura mentioned is actually analysis tool that I just mentioned that iMotions developed. It's called R Notebook. So basically, it's a signal processing tool to help you better extract metrics or values from the raw signal that you collect from biosensors. Yeah, so we also find a lot of other clients getting very interested in those. So just thanks for your sharing, Laura. Yeah, so not only the fragrance testing, so we have talked a lot about that, and iMotions can also be used to test other sensory use cases, for example, cosmetic research. And I'm just going to show you very briefly another study that we have implemented in iMotions. So it's a lipstick product testing. We asked our colleagues to apply the lipsticks, and we recorded the biosignals at the same time. So as you see here, that the workflow is again very similar to what I just showed you. It's a preparation phase, and then product testing phase, reflection phase, and surveys. So here you can see another survey slide here. And what's interesting about this study is that it's unlike a fragrance testing, right? This cosmetic research, it requires people more movement behaviors. So they need to apply the product on their face or on their body, and then we observe during the data collection. So here comes into play the camera recordings. So it's important and also beneficial for your later analysis to actually record what is happening during this data collection, the environment. So we can even add one more camera flows in addition to this fixed recordings. And in this study, we actually mimic a mirroring effect. So the respondent is sitting in front of the screen, looking into the screen where actually she can see herself, and then applying this product while we're collecting the biosignals at the same time. And later on, you can do the annotations or markers, so the tools that we can offer you also from iMotions to do further behavior coding. Yeah, we can understand that different use cases require different workflows. So we already mentioned that each of our clients will be dedicated with the customer success manager to guide you through the beginning of your study design phase and even the sensor connection part. And if you meet some technical challenges, our support team is always standing by. So Laura, if you can you share with us some experiences of this support part from iMotions during your study?
Yes, iMotions support team is very responsive and present when needed, whether it is for the design of the study, setting up pre-test and test, for the data analysis. I regularly had an answer within the day, which is especially important when you are in a test and sometimes have unexpectedly little problems. So yeah, I would especially like to thank all the team, and especially Casper, Samir, and Ariadna, who helped us in all stages for the study. Yeah.
That's very awesome to hear. Shout out to our support team, Samir, Casper, and Ariana, who supported Laura to make all those results and presentation possible today. Yeah, so by saying that, I think I finished my part of the presentation, and let me just keep sharing my screen. Can you see my my slide, just to get a confirmation?
Yes.
Awesome. So before we jump into the live discussions about your questions, I would like to call to connect with all of you. You have multiple ways to connect with us if you want to after this webinar. You can subscribe our iMotions account on LinkedIn, and also visit our dedicated page for sensory and perceptual on our iMotions website, official website. And I know this webinar is too general for you, so if you want a live and customized demo for your own research, you're always welcome to request a demo through this link here, or reach out to Samir directly through this email address that is listed here. And if you come up with more questions after this webinar, feel free to shoot us an email with this email address, and then we will make sure to follow up with you. And we would like a little bit feedback from you if you can click your mouse to give us the answer. So we would like to know how would you like to further connect with us. And I'm going to launch a poll here, very short. Can you see the poll here? Yeah, I think awesome. Just give it a few more seconds so people can think about it and answer it. Come on, let's get more than 50% responses.
Randy, we can maybe start the Q&A while this is running in the background.
Yeah, definitely.
Because
so would you like to start, Samir? Yeah.
Yes, absolutely. I would like to, I have a question for you, Randy. We have a client asking whether it's or not it's possible to use facial EMG in a virtual environment setup. So wearing a VR headset with facial EMG.
Yeah. Well, generally, so for the VR headset, you can understand that you have this mounted headset on the person's face, right? So in that case, of course, if you want to measure facial expressions, then facial EMG will come into play because you are blocking the muscles that can be detected by the camera facial expression. So for facial EMG, that comes with pros and cons. So the pros is that it's more feasible to be used in the VR headset when the face markers are blocked. But the cons are, for example, you get limited metrics from it. So basically what you get is the muscle movement. Then you need to interpret yourself by normalizing or smoothing to change into expressions that you would expect to detect. And of course, there are other best practices that you need to pay attention to during the facial EMG detection. But feel free to follow us more on the website or talk to us later. But yeah, it's possible, but with considerations.
Perfect, great. And then I have another question for Laura Gilbert. So I have someone asking, hi Laura, are you okay? Oh, sorry, hi Laura, excellent study, congratulations. How was the comparison of results between the emotional questionnaire and the data captured by the biosensors? Was it very different?
Yes, that's a good question. No, the results, the data captured by the biosensor, we compared data captured by the biosensor and a result from the questionnaire, and they were highly correlated. But yeah, with the biosensor, we did not succeed to obtain a significant statistical difference between orders, but there were the tendency we see were confirmed by questionnaires, and we saw that the sense which obtains the highest physiological valence obtains the highest liking score, and also the highest the sense with the highest arousal obtained the highest dynamism score with the indirect evaluation, and also with the questionnaire. So there were high correlation between both.
Okay.
Yeah.
So in other words, they were more like supplementing each other rather than being two different like, you know, responses, right?
Yeah, maybe.
Perfect. All right. So then I have 2 or 3 questions I would like to address myself. The first one is, I'd like to know if you analyze competitors to differentiate brands. The question is, well, that depends on what is the goal of the research, right? So we have a lot of our fragrance houses. They will like compare a lot of different brands because they are working with a variety of different brands, where some of our like brands, end clients for the fragrance houses, the cosmetic brands, they will just test their own products. But again, it also depends on what is the goal. If the goal is to test these, for example, fragrance product under the R&D phase, where you have like different, what do you call it, like design routes or like different variants of the final product, then you can test these different variants to see which one that works best, or maybe most importantly, which ones not, that doesn't work best, to remove from further consideration, right? In that case, you would test a variety of different variants of the same kind of product. So yeah, my answer to this question is both, basically. It depends on what is the research. And then the second question I would like to address is, in fragrances, aren't especially facial responses tied to the actual smelling part? So when they smell the fragrance, and hard to observe after this. So in the reflection part that both me and Laura presented, yes or no? Yes, in like there would be stronger, of course, when they smell the product. We generally find that when in the actual moment when they smell the product, there will always be a high amount of disgust. And that is not because the respondents are showing disgust. That is just the muscle movements you make when you smell something. That's normal, right? So we recommend waiting 1 or 2 or 3 seconds and then starting the facial expressions analysis after that for just 5 or 10 seconds. In iMotions, you can go in, as Randy showed, you can create markers. So you don't necessarily have to choose the 30-second reflection period. You can just start whenever you want and stop whenever you want. But you are correct. The reflection period that I presented was referred to more for the EEG than the facial expressions. For the EEG and GSR, where facial expressions, it's a bit better to capture it closer to the actual delivery of the fragrance. Cool. The last question is, hello, do you recommend to establish a new baseline between each olfactive simulation, or can you go directly from fragrance 1 to fragrance B? A baseline is good. Like like when we talk about a baseline, we refer to something that you compare your results or your sample up against. Let me address that first. It's good to have a baseline, but again, it depends on what is the purpose of your research. Is it an A/B testing where you want to test like a sample of different fragrances to see which one performs best and worst? In that case, you really don't need a baseline because the results, you will compare them relative to each other. But you can also, if you have a low amount of fragrances that you are testing, like if you are not building a benchmark, then yes, it's a good idea to have a benchmark. And between respondents, we have tried both having people just sit there for 20 or 30 seconds before going to the next fragrance. And we had also people like testing the same fragrance or the same neutral fragrance between each sample, and we haven't found that big of a difference between one another. So it's not really, we didn't find it necessary to have a baseline between the products. All right. Randy, do you have any questions that you would like to address?
No, I think everything is clarified very nicely by you.
Thank you.
All right, do we have more questions that we want to address here? Otherwise, they can always shoot the questions into the emails to us later.
And if you have a little bit of time, please, we are hosting a 5-day academy a few times a year, where you can come to one of the 4 locations, Singapore, Boston, Australia, or Copenhagen, and spend 5 days with our team to actually learn in details how to use all these biosensors in your particular research. Go into iMotions.com/academy, and you can see more about that.
Awesome. All right. By saying that, we need to say goodbye now. Thanks, Laura, very much. Thank you very much. And Samir for your amazing presentations today. And thanks everyone for joining us today. Have a nice rest of the day and stay connected. Bye.